think of your function as like this little machine here. Here's our function machine, f. Right, and over here we have this domain set. And values from our domain can come in, and if f works and spits something out, so if we have an x value, and we put x into f, and it manages to spit out f of x, all is good. If, however, we take another, I don't know, we'll call it x prime, and we put it into f, and uh-oh, f is broken. That means that x prime does not get to belong to the domain, but x does. So the things that are in the domain are the ones that our function works for, and the things that are not in the domain are the things that cause it to break. Things that make us divide by 0, take square roots of negative numbers. What are some other weirdnesses that happen? I don't know. Those are the two most common examples. Square roots of negatives and dividing by 0. All right. So the range now is what actually comes out over here. The range is what f spits out. So the range is going to be the biggest set of numbers. So think about a squaring function. What sorts of numbers come out when you square things?
But
If I take a number and I square it, what do I know is going to be true about the number I get as a result?
that it's going to be that if you took the square root of the number that you just squared, it's going to give you the same number.
Okay, so you've just jumped ahead to inverse functions.
Yeah.
Hold on, we'll get
Whoops.
there. No, that's good. That's good. That's actually a really good way to be thinking about things. Let me ask you this. Is it possible for me to take a number, square it, and get negative 7?
Nope.
Why not?
Because a negative times a negative is a positive.
Okay, so what have I just ruled out from the range of the squaring function?
All negative numbers.
Right, it can't possibly be in its range because there's no way to square something and get a negative value. Okay, now, it turns out that almost always the simplest way to determine the range of a function is to graph it. And you're going to look at the graph and you're going to look at the y-axis going up and down, and you're going to see what's the smallest value on that y-axis that it takes, what's the largest value on that y-axis that it takes, and those tell you what your range is. Okay, so graphically speaking, we get a new if we have a function that's doing something like, I don't know, that as an example, then we look along the y-axis, and this is our highest value, and this is our lowest value for said function here.
So everything between that and that is the range.
Exactly. Right there is our range. Okay, now a lot of functions go up to infinity and down to negative infinity, so their range is infinite. But like the squaring function, we know we can't get the negative numbers in our range. Are there any positive numbers we couldn't get?
Well, you can't get what's the term? It's not a square root, but it's a perfect. You can't get non-perfect squares.
Well, you can, but they would just be decimals.
Right, exactly. You can't get integer answers for non-perfect squares, but certainly every positive number has a square root, right? So, and let's take the corresponding, no, this is the wrong one. Let's look at the graph here. There it is on the standard window, right there. So, again, looking at the corresponding values on the y-axis. I start down here at 0, that's the bottom of my range. Right now, it doesn't look like there's a top to the range. Now, of course, any graph that you draw, you're looking at a finite limit, so you're kind of making some assumptions about what the range actually is because you can never see the entire picture. But we will start to build up enough tools to help us evaluate functions to know whether or not the picture that we're seeing is enough of it to make those judgments. Now, I can, let's look at this. I made my y value even higher, and I can see I'm still getting up there. If I make this negative 20 to 20 and set this from negative 20 squared to 20 squared. Again, I now have 400 as my maximum value. I'm still managing to get there. I can see that that's still in my range, and I can continue this process on and get as high as I want on the range. So in this case, for y equals x squared, our range is all positive numbers. How do I write that? And actually 0 is in the range as well, so how would I write that? Using the kind of notation we were talking about
Open
yesterday.
parentheses,
Okay.
0, comma, infinity.
Okay. Is 0 contained in my range?
Yes.
Yes. So I actually want to bracket that. There. And that would be the range of y equals x squared.
Oh, no, never mind.
Are you sure you don't have a question?
No, infinity is not a number, so it is an open